Go outside on a clear night, far from any city, and look up. You'll see a few thousand stars, and between them, black. Ordinary, unremarkable black. That blackness is the strangest thing in the sky. Because if the universe goes on forever and it's filled with stars, then every direction you look, every single line your eye can follow out into space has to end on the surface of a star eventually. Not most directions, all of them. Which means the night sky shouldn't be dark. It should be a solid wall of light, as bright as the surface of the sun, in every direction, all night, every night. It shouldn't just be bright, it should be cooking you. It isn't. And working out why took nearly 400 years. The answer turned out to be one of the biggest things we know about the universe. The obvious objection is distance. Stars far away look fainter, so surely the distant ones barely count. They are fainter. Light spreads out as it travels, and a star twice as far away looks 4 times dimmer. That's the inverse square law, and it's real. But you have to count as well as dim. Picture the universe as a set of nested shells centered on you, like the layers of an onion. Take a shell twice as far out. Every star in it is 4 times fainter, but that shell also has 4 times the surface area, so it holds 4 times as many stars. 4 times dimmer, 4 times more. The two effects cancel exactly. So every shell, no matter how far away, sends you the same amount of light as every other shell. The one 1,000 light years out, the one 1 billion light years out. Identical contributions. Now stack up an infinite number of shells, each adding the same amount of light, and you don't get a big number, you get infinity. In practice, it stops short of infinity because nearby stars block the ones behind them. That's not much comfort. The place it stops is a sky uniformly as bright as the surface of a star. There's a cleaner way to feel this. Stand in a forest that goes on forever. Right in front of you, there are gaps between the trunks. But look further out, and the trunks behind start filling those gaps. In a truly infinite forest, no line of sight escapes. Every direction ends on wood. An infinite universe full of stars is that forest. Every direction should end on fire. This is called Olbers' paradox, after the German astronomer Heinrich Olbers, who wrote it up in 1823. He wasn't the first to notice. Thomas Digges was circling it in 1576. Kepler flagged it in 1610 and drew the only conclusion available to him, that the universe must be finite, with a wall around it. Edmund Halley and Jean-Philippe de Chasseau both took runs at it in the 1700s. It stuck around because it is genuinely hard. And notice that it isn't an observation problem. You don't need a telescope. You need to explain why walking outside at night doesn't kill you.
The first answer people reached for, including Olbers himself, was that something is in the way. Interstellar dust and gas soaking up the light of the deep universe before it can reach us. It's a reasonable guess. There genuinely is dust out there, and it genuinely blocks light. But it doesn't work, and the reason it doesn't is beautiful. If dust absorbs starlight, it heats up, and anything that heats up radiates. Leave that dust sitting in a sky, pouring energy into it for long enough, and it reaches equilibrium, emitting exactly as much energy as it takes in. At that point, the dust isn't a shield. It's another glowing surface at the same brightness as the stars it was hiding. You cannot hide an infinite amount of light behind a curtain. In an eternal universe, the curtain becomes a lamp. That's the pattern with this paradox. Every solution that works by blocking the light is killed by thermodynamics. To get a dark sky, the light has to genuinely not be there. Here's the second escape route, and this one is closer to the truth. Maybe there simply aren't enough stars. Stars are not eternal lamps. They burn a finite amount of fuel, and they have a finite amount of energy to give. Our sun has enough hydrogen for roughly 10 billion years, and then it's done. So even in an infinitely old universe, you can't accumulate infinite starlight. Every star has a budget. And when you run the numbers on the universe we actually live in, the shortfall is spectacular. To fill the sky with overlapping stars, your line of sight would have to run something like 100 billion trillion light years before it hit a surface. Stars are nowhere near dense enough for that. So the sky is dark partly for a very boring reason. Space is mostly empty, and stars are tiny compared to the gaps between them. But that only pushes the question back. If the universe were infinite and old enough, we could still afford to look far enough out. So the real question isn't how many stars there are, it's how far we're allowed to see. Light is fast, but it isn't instant. A bit over a second from the moon, 8 minutes from the sun, 4 years from the nearest star. When you look at something far away, you are looking at it late. And the universe has not been here forever. It has an age, about 13.8 billion years. Put those two facts together and the paradox dissolves. If a star sits 40 billion light years away and the universe is only 13.8 billion years old, its light is still in transit. It hasn't arrived. It's not faint. It isn't here yet. So, however infinite the universe might be, you never get to add up infinite shells. The sum is cut off, and it's cut off early. It's worse than that for the paradox, and better for us. The stars haven't been shining forever either. For the first few 100 million years after the Big Bang, there were no stars at all, just cooling gas in the dark. Astronomers call it the cosmic dark ages. So when you look far enough out, you aren't looking at faint stars, you're looking back to before there was anything to look at. The first person to publish this, remarkably, wasn't an astronomer. It was Edgar Allan Poe in an essay in 1848. The light from the far universe simply hasn't had time to reach us. Lord Kelvin made it rigorous in 1901. Both were decades ahead of the astronomy.
This gives every one of us a boundary. Not a wall in space, there's nothing there, but a limit on how far light has managed to travel since the beginning. It's called the observable universe, and it is the only part of everything that can possibly affect you. You'd expect it to be 13.8 billion light years across, the radius, 1 light year per year. It's bigger, about 46 billion, because while that light was traveling, space itself was expanding underneath it, carrying its source further away. The light took 13.8 billion years to arrive. The thing that emitted it is much further out now than it was when it let go. Whatever lies beyond that boundary, and there's every reason to think a great deal does, isn't dark. It just isn't ours yet. Its light is still on the way, and some of it will never make it. Inside the boundary, the number of stars is finite, and a finite number of stars makes a finite amount of light. Paradox over. Expansion does a second thing on top of that, and it's worth knowing. When light crosses expanding space, the space it's crossing stretches, and the light stretches with it. Wavelengths get longer. Longer wavelength means less energy per photon. Blue slides to red, red slides to infrared, and eventually out of anything your eye can register at all. It also spreads the photons out in time, so fewer of them arrive per second. Both effects dim the distant universe on top of the ordinary inverse square dimming. So even the light that does reach us from far away arrives faded, reddened, and thinned. Expansion isn't the main reason the sky is dark. The finite age does most of that work. But it's why the deep sky stays dark even where the light has made it through. Except The story has one more turn, and it's the best part. Olbers was right. Every line of sight really does end on a hot, glowing surface. It just isn't a star. Wind the universe back far enough, and it was hot, dense, and opaque, a fog of plasma glowing in every direction at once. About 380,000 years after the Big Bang, it cooled just enough for that fog to clear, and all of that light was released everywhere simultaneously. It's still traveling, and when you look out in any direction far enough, you eventually reach the moment that fog cleared. Every single line of sight ends on it. The sky is a wall of fire, exactly as the paradox demands. The catch is what 13.8 billion years of expansion did to it. That surface was glowing at around 3,000 degrees, orange-white, like the filament of a bulb. Expansion has since stretched its light by a factor of about 1,100. 3,000 degrees has become 2.7 degrees above absolute zero, and visible light has become microwaves. We found it by accident. In 1965, Arno Penzias and William Wilson were fighting a stubborn hiss in a radio antenna in New Jersey. They cleaned pigeon droppings out of it, trying to make the noise go away. The hiss was the cosmic microwave background, the glow of the early universe arriving from every direction at once. It's still passing through you. Around 400 of those photons in every cubic centimeter of the room you're in. For every atom in the universe, there are roughly 1 billion of them. So the answer to why space is black isn't that there's nothing out there. It's that nearly all of what's out there arrives at wavelengths your eyes were never built to see, from a universe that started too recently to fill the sky. And that flips the whole question around. The darkness of the night sky is not an absence of information. It is information. It's a measurement anybody can make with no equipment on any clear night. And it rules out an infinite, eternal, unchanging universe full of stars. That model predicts a blazing sky. We don't have one. Which means the plain fact that you can see stars as separate points with gaps in between is telling you the universe had a beginning. People stared straight at that clue for 300 years before anyone was willing to believe it. So the next time somebody calls space empty, you can give them the better version. Every direction you look ends on a surface that was once as bright as fire. The universe is glowing everywhere, all the time, from everywhere at once. It has just been stretched so thin by so much time and so much expansion that what reaches your eyes is a whisper instead of a blaze. Space isn't black because it's empty. It's black because it's young and because it's still growing. If this rearranged something in your head, subscribe and tell me in the comments what the oldest light is that you've ever thought about. Because tonight, doing nothing at all, you'll be sitting in light that is 13.8 billion years old.